Hey guys, we are back with another video, and today we'll be discussing problem 21 from the 2024 AMC 12B. Now I'm going to be really honest. For number 21 on this test, this is a really simple problem to solve. And the approach is pretty simple too, but before we get to that, let's read the question. The measures of the smallest angles of three different right triangles sum to 90 degrees. All three triangles have side lengths that are primitive Pythagorean triples. Two of them are 3, 4, 5 and 5, 12, 13 right triangles. What is the perimeter of the third triangle? Okay. So what I'm going to do first is I'm going to draw these triangles. Right. So there's our 3, 4, 5 right triangle. And there's our 5, 12, 13 right triangle. And we know that the smallest angles will be opposite the shortest side of the right triangle. So I'm going to call this angle theta 1 and this angle theta 2. And then we have our third right triangle. Right? Oh, not like that. We have a third right triangle. Call this angle theta 3. This is x, this is y, and this is z. And what we want to find is x plus y plus z. Right? Given that we know that the greatest common factor of x, y, and z is equal to 1. Because that's what primitive Pythagorean triples means. It means that the GCF of all three sides is 1, or that this triangle side length isn't a multiple of a Pythagorean right triangle. Alright, so let's get to it. We know that theta 1 plus theta 2 plus theta 3 is equal to 90 degrees. Right? So what I'm going to do is take the tangent of both sides. So I'm going to say tangent of theta 1 plus theta 2 plus theta 3 is undefined. Means it's something over 0. Right? So what I'm going to do is I'm going to break theta 1 plus theta 2 plus theta 3 into theta 1 plus theta 2 as one quantity, and then theta 3 by itself. So what I can do then is write this side using the tangent addition formula for two angles. So I can write this as tangent of theta 1 plus theta 2, right, plus theta 3, or so rather tangent of theta 3 over 1 minus tangent theta 1 plus theta 2 tangent theta 3. Right? This is our expression so far. Let's keep working with it. Now our main objective is to simplify this. Right? We need to find a value for this. Because, well, frankly, we know what tangent of theta 1 and tangent of theta 2 is. Right? So we're going to find that value right now. So we know tangent of theta 1 plus tangent of theta 2 is equal to tangent theta 1 plus tangent theta 2 all over 1 minus tangent theta 1 tangent theta 2. And if we look back at the triangles we drew, tangent theta 1 opposite over adjacent 3 over 4. So tangent 1 is 3 over 4. Tangent theta 2, similar story. Opposite over adjacent, 5 over 12. If I'm not mistaken, yep, it's 5 over 12. So let's plug in those values. So this fraction then becomes 3/4 plus 5/12 all over 1 minus 3 over 4 times 5 over 12. Right? So let's simplify this. The denominator, we get 1 minus 15 over 48. And at the top, we get over 48, of course. 36 over 48 plus 20 over 48. Which is, when you simplify it, it equals 56 over 33. Because it's 56 over 48 over 48 minus 15, which is 33 over 48. That's just 56 over 33. So we know tangent theta 1 plus tangent theta 2 is 56 over 33. I'm going to box that. Right? And now we'll come back to our expression here. Right? Put this down here. Oh, okay. Notes is refusing to cooperate. Alright, so our previous expression was tangent theta 1 plus tangent theta 2 plus tangent theta 3 all over 1 minus tangent theta 1 plus theta 2 times tangent theta 3. And we wanted this to be undefined. Correct? Well, we know what tangent theta 1 plus theta 2 is. So I'm going to substitute those values. So this is equivalent to 56 over 33 plus tangent theta 3 all over 1 minus 56 over 33 times tangent theta 3 equals undefined. And remember, for the case of tangent, undefined only occurs when this bottom part is equal to 0. So now we have a concrete way for solving for tangent theta 3. 1 minus 56 over 33 tangent theta 3 0. This is equal to 1 equals 56 over 33 tangent theta over 3. Right, and we get tangent theta over 3 is the reciprocal, 33 over 56. But we're not done quite just yet, although we're very close. Let's draw our triangle with angle theta 3. Right? We said this was our angle theta 3. And remember, theta 3 is supposed to be the smallest angle in this right triangle. So theoretically, it should be opposite the smallest side in the triangle. And we know tangent is opposite. So the opposite side I'll call x. And over the adjacent, which I'll call y now. So x over y, 33 over 56. We know x is less than y, so x has to be 33. Right? So we know which side is which now. So I'm just going to erase this really quick. Okay. So we know the side opposite theta 3 is 33. And this side over here, the adjacent side, is 56. Now, all we have to do is find the hypotenuse. Now, this side is just square root of 33 squared plus 56 squared. Now, let's bust out some arithmetic and find out the side length of that. 33 squared is 1,089. 56 squared, oh, I don't have that memorized, so let me just find out what it is. Alright, 56 times 56. 336. This is 0. 28, 6, 3, 1, 3. It's equal to 3,136. And if we add these two up, we get 5, 2, 2, 4. We get 4,225. Now, the square root of 4,225, that might be a whole number. Let's see. I'm going to try. It ends in a 5. And 75 is too big. 75 squared is bigger than 4,225. 55 is too small. So 65 might be the answer. So I'm going to try multiplying this out. Let's see. So this is 5, 32. Okay, that's done. 3, 39. 5, 2, 2, 4. Well, would you look at that? Turns out that the square root of 4,225 is indeed 65. So we know the dimensions of our right triangle. It's a 33, 56, 65 right triangle. And what's the question asking again? What's the perimeter of the third triangle? Well, we know how to calculate the perimeter of a triangle. Just got to add all the sides up. 33 plus 56 plus 65. This is 89. So if we add that to 65, what do we get? We get 140 plus 14, or 154. And that's answer choice C. And we're done. Thank you for watching, guys. I hope you learned something from this explanation, and I'll see you very soon.